record this. All right. So on Wednesday, we started talking about some right triangle stuff. Okay. And you guys tell me what's anything, or you can throw it in the chat or just shout, what's something you remember from Wednesday, just kind of to get us started. Hey, all right, I remember we talked about this, and it can be as specific or as vague as you want. What's something you remember though? So we talked about a lot of things actually. No? Okay. We'll tell you what. So we talked a little bit about a couple things. We said we did some SOHCAHTOA, and we also talked about this thing called Pythagorean theorem. And you guys were pretty good with Pythagorean theorem. And that was just if it's a right, Pythagorean theorem. If it's a right triangle or there's a 90-degree angle in it, all right, you can use the Pythagorean theorem. And that just said a squared plus b squared equals c squared. Okay, so it's a relationship between the side lengths. And just a reminder, c is your hypotenuse, or your longest side that's opposite of your 90-degree angle. So if I draw this little picture here, oh, that's a bad picture. Hang on. The art skills are not on today. It's Friday. Okay. So your right triangle, let's try that again. That's better. So if we draw in our right angle here, your hypotenuse is going to be kind of across we talked about face partners, it's going to be across the triangle from your right angle. So here's your right angle over here, and it's on the far side of the triangle is your hypotenuse. Okay. And then we actually started to talk about a couple trig relationships was the other big thing that we talked about. So I'm going to draw us another triangle here. Okay. And we're still going to have our right angle. So we have our hypotenuse. And we're going to put in our angle measure here. This little circle with the line through it, that's just the Greek letter theta, and it just means angle measure. Okay. All it just means is it's kind of like x. It's just a variable that stands in for we don't know what the angle is yet. Okay. And so we talked about, well, the shoulder partner, or the side that's touching the angle here, that's going to be your adjacent side. If two things are next to each other, you might say they're adjacent. Okay. And the side that is across the triangle from your missing angle, or from your theta, is your face partner, or your opposite side. Okay. So we talked about just labeling triangles, finding the adjacent, opposite, and hypotenuse. And then we kind of put some names to these, and we talked about trigonometric ratios, because really when we do all this, when we look at the hypotenuse, the adjacent side, the opposite side, we're just looking at the ratio, or we're kind of comparing the side lengths. So we had one relationship called sine, okay? And that sine was the ratio of your opposite to your hypotenuse. This is just a quick little review of what we talked about on Wednesday, okay, and just to refresh us. We also talked about another trig relationship, start doing these in a different color, called cosine, all right, cosine, and that was your adjacent side compared to your hypotenuse, so your adjacent over your hypotenuse. And the last one we talked about was tangent, okay? And tangent was the comparison of your opposite side to your adjacent side, okay? Sine, cosine, and tangent. So again, it's just a ratio or a comparison of the side lengths. And so we even came up with a nice abbreviation for this to help us remember. We said that it was SOHCAHTOA because we looked at the first letter in every word. Okay, SOHCAHTOA. All right, because if you look at sine, well, all right, sine starts with S, and then you have to look at the opposite and the hypotenuse. So that's O and H. Okay, so that's how those come about. That SOHCAHTOA. Okay. Today we're going to use SOHCAHTOA, and actually towards the end of class we'll introduce a couple other, there's 3 other trigonometric ratios very similar to what we just talked about. But let's just stick with SOHCAHTOA for a minute. Okay. And we're going to draw ourselves a triangle. I'll make this one a little bigger for us just so we can see it. All right, so here's our right angle. And this time we're actually going to say this is a 30-degree angle. We're going to know that that's a 30-degree angle. Okay. And then let's just say for fun, our hypotenuse is 8, and we don't know the length of this other side of the triangle. Okay. So first thing when we do this, all right, again, our goal, if they had instructions on this, our goal is going to be, let's solve for x. Okay. So first thing we need to do is, what two sides do we have here? You guys take a look. And what do you see? What two sides in relation to this angle do we have? You know? Thoughts or ideas? What are,
You mean
well,
like
we
the
know if
type?
we go ahead, somebody's starting to talk.
You mean like the type of side? Like
Yeah.
angle of
So do we have
hypotenuse?
the opposite? Do we have the adjacent? Do we have the hypotenuse?
Yeah, I think adjacent because x is next to the angle that we have, and then
Yeah.
hypotenuse because that one's the longest.
Okay. So this is our adjacent side because it's touching, it's kind of our shoulder partner to our angle. Okay. We also have, if we go across the triangle from our 90-degree angle, this would be our hypotenuse. Okay. Does everybody see how we have the hypotenuse? Just give me a thumbs up, maybe, something like that. Okay. So knowing that we are trying to create a trig ratio with the adjacent side and the hypotenuse, well, let's go look at our abbreviation. The only one that has adjacent and hypotenuse is cosine. Okay. So we would say the cosine of 30 degrees. Well, cosine said take your adjacent and divide it by hypotenuse. Well, our adjacent side is still x. We don't know that yet. And then our hypotenuse was 8. Okay. Our goal in these types of problems is going to be, let's solve for x. Okay. Let's solve for x. Well, if we want to get x by itself, just multiply. We can multiply both sides by 8. Okay, I know I'm kind of running out a little bit of room there. So we could say 8 times the cosine of 30 equals x. Okay. And one of the things we didn't get to talk about on Wednesday was, I'm going to stop sharing my screen for a second, is that you can actually solve this. All right. If I share my screen, if you plug in a calculator, hang on one sec. I had it pulled up. Okay. If I share my screen, are you guys seeing my calculator right here? You seen the Google calculator? Okay. We're not gonna, in this class, we're not gonna talk about what's called radians. So make sure when you do this, you do it in what's called degrees, right? We measure a circle. If you do a full circle, that's 360. Maybe my snowboarding or skateboarding people, you know, all right, it's a 360 all the way around. We're just gonna talk about everything in degrees. So you can plug in the cosine of 30 degrees and it's gonna spit out a number, okay? This 0.866 number. So you could, in our problem, we said 8 times the cosine of 30 degrees. You can actually plug that in a calculator and it will give you your exact value, okay? If you guys want to go to 2 or 3 decimal places, that's good enough for me. This isn't chemistry class where you got to have sig figs or anything, okay? So again, let me get back my iPad here for a second. We said 8 times the cosine of 30, and you can just plug cosine of 30 in. Okay. So again, we're down here 8 times the cosine of 30. We got 6 point, what did we have? 6.92. All right, we'll round it to 93. All right. And that would be the length of this side. That would be this side length. Okay. Questions or concerns on that? Anything, can you go through that step again? Okay. Let's do one more, and I'll kind of give you guys a chance to get started on it, and then um, I'll kind of catch up. Okay. Um, so I'll let you guys get a head start on me. Here's gonna be our triangle, and this triangle, all right, draw on our right angle. Um, this triangle, we're gonna have, this is gonna be a 45-degree angle. And in this case, we're gonna say our hypotenuse is 6, and we wanna know the vertical side length, all right? We wanna know this side right here. How long is it, okay? So go ahead and take a minute, figure out which trigonometric ratio. Am I gonna use sine, cosine, or tangent? Which one am I gonna use based on the two sides we have? And then go ahead and get that ratio set up, all right? Questions on that, how we solve that? We figured out, number one, we need to use sine because we had opposite over hypotenuse. And then we got x by itself. Okay. Questions on anything there? All right. The last thing we're going to talk about today, I mentioned at the beginning of class that we're going to have a couple other trig ratios. Okay. And so far we've talked about sine. All right. We talked about cosine, and I'm just using the 3-letter abbreviations here, and tangent. Okay. What we're going to talk about 3 other trig ratios. Okay. And what those are called are secant. Oh, hang on one sec. I don't want that there. There's secant, cosecant. So we're going to have secant, cosecant, and cotangent. Okay. It's just the name of a few other trigonometric ratios. Okay. The way I remember which one, and the way I remember it, you notice how sine, there's no prefix co in there, okay? When you go from sine matches up with cosecant. So if there's no co, you have to add it. Cosine, it has that prefix co. So we dropped it. There's no co in the one that goes with cosine. There's no co in secant. And then tangent didn't have any co prefix, so we added it. So if it doesn't have it, you're going to add it. If it already has co, then you're going to drop it. Okay, and what I mean by that, you know that sine is opposite over hypotenuse. Okay, cosecant is just the opposite. All right, I shouldn't use the word opposite because we're using that here. It's the reciprocal. It's the hypotenuse divided by your opposite side. Okay. Similar, you know that cosine is adjacent over hypotenuse. And so secant is hypotenuse over adjacent. Okay. Notice how we're just taking it and we're just doing the reciprocal, or I call it the reciprocal sometimes, just so you remember what that word means. You flip the numerator and denominator. Okay. And I bet you guys can guess that tangent is normally opposite over adjacent. Okay. Well, cotangent is just adjacent over opposite. You're just flip-flopping your numerator and denominator, creating the reciprocal. Okay. Again, these, just to kind of recap, sine went with cosecant. Sine didn't have that co in it, so we had to add it. All right. Cosine goes with secant because cosine already had a co in it, so we had to drop it. And then tangent and cotangent, those are kind of the easy ones to remember. Tangent and cotangent go together. Okay. So last thing we're going to try and do, all right, we're going to look at our triangle. Okay, we're going to create a triangle, and we're going to try and create all 6 of our trigonometric ratios. Okay. So here's our right angle. This will be our theta. And we're going to make this a 5, 12, and we'll say this is 13 triangle. Okay. So first off, what's sine going to be? If this is our angle, sine says opposite over hypotenuse. What would you guys say?
(12/13).
Yeah, good. Okay, 12/13. If we wanted to do cosecant, and now don't ask me why mathematicians abbreviate this, but cosecant, for whatever reason, is abbreviated CSC, okay? All that is just hypotenuse over opposite. Well, it's just the reciprocal of that, okay? So your cosecant ratio would just be 13/12, all right? What about cosine? What do we say cosine is in this case? If here's our, again, here's our theta, adjacent over hypotenuse.
5/13.
Yeah, 5/13. And so our secant ratio, now that mathematicians get back to normal, they just use the first three letters, okay, is going to be 13/5. All right. Tangent, you guys can guess. All right, let's do opposite over adjacent. Our opposite side is 12. Our adjacent side, the shoulder partner, is 5. Okay. Well, cotangent is just going to be the opposite of that. It's going to be 5/12. Cotangent says adjacent over opposite. Well, yeah, our adjacent side is 5, and our opposite side is 12. Okay. So we can kind of use these 6 trigonometric ratios. And when you guys go on to Mr. Fiddler's class and you take him for trig, or honestly, maybe Miss Engel next year for geometry, you guys will use all 6 of these, okay? So we just kind of want to get you started with, all right, I've seen these. I start to know how these ratios interact with one another. I can do sine over cosine, things like that, okay? Questions on anything with that? How'd you do that? Why did you call it that? I think I figured out with cosecant, if you take a look for a second, cosecant, they can't use the first 3 letters of it because that would be the same as cosine. So that's why they had to go to CSC. Just kind of, so just think about but don't let the 3-letter abbreviations freak you out, okay? Mathematicians are just lazy. That's their fault, okay? Stuff from you guys. And today was a little bit of review, but then I know we did some new stuff, but it was definitely building off what we did Wednesday. So, I don't know. Thoughts, feedback? All right, I'll tell you what, it is 11:56. I will hang out here as long as you guys want. If you want to do the homework and just check in with me, say, hey, Mr. Jones, am I doing this right? Or can you help me get started on this one? I'll hang out as long as you guys need. But if you want to get out of here and go get lunch or go take a noon nap or something like that, you can do that as well. Okay? Last thing I'll say, again, Monday will be review day, so we'll come in. We can kind of do some problems together. If you have individual questions, we can do that. And then Wednesday, you do need to come to the live Zoom so you can take our quiz. Okay? I think I was making it yesterday. I think our quiz is either 11 or 12 questions. I'd have to check. And there's two trig questions. So there is a little bit of trig, but there's some logarithm stuff and there's some rational stuff too. So, but yeah, that's all I have for you guys. So if you want to hang out and do stuff, that's fine. If you want to get out of here, that is perfectly